Hello everyone, welcome to aplusbi. This channel is all about complex numbers, and in this video we're going to be solving an interesting equation with complex numbers. And as before, I'll be presenting two methods, and I have another channel called Cybermath if you like algebra, number theory, and trigonometry problems, especially competition level problems or challenging problems or puzzles. I think you're going to love this channel. Let me know what you think. Now, we have this equation z squared minus the quantity 2 plus I multiplied by z, and that equals some other complex number, 1 minus 7i. If you're new to complex numbers, by the way, go ahead and check out my lecture videos and ask a lot of questions. That's how you learn and get better. So, how do we solve a problem like this? Now, what is the name of this channel? That's something you should always remember, A plus BI. And A plus BI gives you a very good clue, actually, for solving most equations with complex numbers. I say most because some equations are harder than others. But in general, this is a good strategy, replacing z, because z is a complex number. Did I say that? With A plus BI. But what is I? I is the square root of -1. Therefore, we can also define it as I squared equals -1. So it's the number whose square equals -1. We know that it's not real. It is imaginary. That's why I is the name of it. Okay? Great. So hopefully I said that. And now we're going to go ahead and proceed with our general universal method, replacing z with A plus BI. And the reason, why not? Right? Okay. What happens if you replace z with A plus BI? Of course, you have to think about z squared. What is z squared? It's A plus BI squared. You've got to be careful. The only thing you need to think about here is that the fact that I squared is -1. So if you square this, you're going to get A squared plus B squared I squared plus 2ABI. But because I squared is -1, this is going to turn into A squared minus B squared plus 2ABI. So you can also memorize this as a formula because this comes up a lot. Trust me, I have a bunch of problems on my channel. I made playlists, by the way. You can start with the lecture notes if you're new to complex numbers. And if you're not new to complex numbers, let me know what you think. So we got z and z squared. Why don't we just plug it in, right? So on the left-hand side, we start with this, which is z squared. And then to that, we subtract, or from it, 2 plus I multiplied by z, which is A plus BI. And the right-hand side is 1 minus 7i. So we have two complex numbers that are equal. Our goal is to find the values of A and B from here. Can we find it? I mean, we should be able to, right? So let's go ahead and give it a try. First, we're going to keep this as is, because we need to distribute these things. 2A plus 2BI, 2B or not 2B, sorry about that, just came up, plus AI, not the artificial intelligence, but a different one, plus BI squared, that's a minus B, as you know, is equal to 1 minus 7i. Now we're going to go ahead and negate everything inside the parentheses and put the real parts and imaginary parts together. So can I do this? 2A squared minus B squared, I want to bring this over as a minus 2A, and I want to bring this as a plus B because they're being negated. And then I have the 2ABI. 2AB is part of the imaginary part. And then we have 2B plus A, or we can just write it as minus 2B minus A. And the whole thing is going to be the coefficient of I, which is called the imaginary part. So a complex number has a real part and an imaginary part, but they're both real, which is weird, right? Kind of. So here's what we have so far. And guess what this turns into? This turns into a system of equations. Ta-da-da-da, don't you love that? Now this is supposed to be 1, and this is supposed to be -7, in order for these two numbers to be equal, right? Makes sense? Now, because if two complex numbers are equal and their real parts are different, it's impossible. It can't be happening. And of course, once the real parts are equal, the imaginary parts also have to be equal because you're left with the imaginary parts only. If you think about it, the proof is fairly easy, but it's a good exercise. Now, let's go ahead and write this as a system. And this is a quadratic system, which should be solvable by substitution or maybe even elimination or a combination of both. Well, we got the following system, and how do you solve it, right? One thing to think about. And usually, for these kinds of problems, substitution works well, but I got to be able to isolate one of the variables, either A or B. In this case, I can isolate B, but both of these terms have B in them. And these both have A in them. So before I isolate one of the variables, I need to use factoring. Okay, which one should I do? It's totally up to you. We can start with these two, which means I'm going to factor out a 2b, or just b is fine as well. If you factor out 2b, you get a minus 1, and then minus a equals negative 7. Let's go ahead and add a to both sides. 2b multiplied by a minus 1 is equal to a minus 7. And finally, if you divide both sides by a minus 1 multiplied by 2, which I guess makes sense, so I would probably just distribute it and divide by that, 2a minus 2. So this gives you a formula. B is written in terms of a, which means we can take that and plug it into the first equation. This I call the first, and this I call the second. Now we're working with the first equation, and I'm plugging in this for b, which is a minus 7 over 2a minus 2. I need to square that, minus 2a, which is 2a, because a is unchanged, plus b, which is a minus 7 over 2a minus 2, and then finally plus b, I did that, equals 1. Beautiful. So now I got a single equation with a single variable, which is good, because now we can go ahead and work it out. Uh-oh, Houston, we have a problem. Guess what? We're going to get a quadratic and then a quartic. That's not very good, is it? But yeah, this is problematic. What would happen? Now, on the other hand, you can always look for an easier way out. Would it be better, easier, if I was able to isolate a, like writing a in terms of b? Would that be easier? Let's go ahead and check it out, okay? So I'm going to take these two things. So factor out an a, 2b minus 1, and then add 2b to both sides, and then isolate a, and we get that. That looks a little cleaner, but if you plug it into the first equation again, you have a squared minus b squared. Looks like we're going to run into the exact same situation, so it wouldn't matter. No big deal. We can proceed with this. But here's what's going to happen. Let me tell you. You're going to square this. I can just square it, right? Oops, I don't want them to stick together. They need to be separated by space. And this is just going to be 4a squared minus 8a plus 4, something like this, right? 2, 1, 2, 1, okay. And then this one, you know what? I might just put the 2a on the other side, maybe. I don't know. It's probably easier because I'll make a common denominator. So as you can see here, once I start making a common denominator, I'll start with something like 4a to the 4th power, and then minus 8a cubed, so on and so forth. And then our denominator is going to be quadratic multiplied by that. That's going to be cubic. Of course, you need to take care of this as well. And at the end, you're going to end up with a quartic equation, which is going to be hard to solve, but I'm going to leave it as an exercise again for the reader, for the viewers. Let me know what you find, okay? Now, let's go ahead and proceed with the second solution because I think the second solution is easier. The first one is kind of like very brute forcey, which is not meant to be used, but I still showed you how to do it because that's a general method, and I like presenting multiple methods, okay? Now, here's our second method. This is a quadratic equation, isn't it? So why not use the quadratic formula? But let's go ahead and make it a full quadratic first. So we're going to bring this over, like maybe write it like this. I don't want to use a minus sign there, equals 0. Now, this is a quadratic equation like this, az squared plus bz plus c. And guess what? Even when the solutions are complex, the quadratic formula, or when they're non-real, like in this case, the method still works, okay? So here's how it goes. Z is equal to negative b plus minus the square root of b squared. So I got to square this minus 4ac. A is 1. So I'm just going to multiply that by negative 4 and divide the whole thing by 2a, which is 2. Great. Let's go ahead and square the terms inside the radical. And it's going to give us 4 plus I squared minus 1 plus 4i minus 28i plus 4. So we're going to have to deal with that. And let's simplify a little bit more. 2 plus I plus minus. Now we have 3 minus, 3 plus 4, which is 7, right? This 3 plus 4. And then minus 24i. This is a good thing, let me tell you. Why? We need to find the square root. Now, to find the square roots, you have a couple different ways to do it. You can say, okay, because a plus bi solves a lot of problems, you can set it equal to a plus bi. It's different from the other a, b we talked about. And then square both sides and find a and b. which it will be 1. Oops, I forgot to write 24. I don't know why I wrote 2. 24i. And you can find the values of a and b. Or you can think of another way to do this. If you think about it, actually, there's a triangle, which is the 7, 24, 25 triangle. And you know why? Because 25 squared minus 24 squared is equal to 7 squared, or 7 squared plus 20. But this is easier to look at because of difference of 2 squares. Does that make sense? Hopefully it does. Think about difference of 2 squares, and you'll get it. So does that help at all? Well, we have a number whose modulus is 5. So the modulus of the square root is supposed to be something like a number whose modulus is square root of 5. Does that make sense? Yeah? So I can think of a couple numbers like 1 plus 2i maybe, or 2 plus I as some number whose modulus is square root of 5. Would that work, right? That would be interesting. Actually, never mind. I meant to say, I think the modulus, okay, let's think about it this way. What's the absolute value of this number? It is the square root of 7 squared plus 24 squared, right? And this is 25 squared, so it's 25. Never mind. It's not 5, it's 25. So the square root, the modulus of the square root is the square root of the modulus, which means this, okay, this is what I'm trying to say. The modulus of this, the absolute value of this is supposed to be 5 because it's the square root. So I was actually right when I said the first thing, right? So it's not the square root of 5, yes. So which number can have a number with modulus 5? So when you add, in other words, it's going to look like this, which means it's going to look like this. Now this is helpful. Let me tell you why. Because when you square both sides here, you're going to get 7 minus 24i, and I'll show you an alternative method I can. If you square this, you're going to get that, right? From here, you get a squared minus b squared is 7. Look, these two pieces of information is super helpful because you don't have to get into the quadratic system, so on and so forth. You can just solve this system instead, right? 2a squared is 32, a squared is 16. So from here, a can be 4 or negative 4, right? And if that's the case, for example, if a is 4, b squared is 16, 9, so b can be 3 or negative 3. But of course, not all these cases are going to work, but I'm still giving you all the possibilities. Now, what you need to do is check which cases will work for you, right? And there are 2 squares, so if you can find one correctly, then we should be good. So in other words, we're kind of looking at a number like 4 plus 3i, 4 minus 3i, negative 4 plus 3i, and negative 4 minus 3i with all the a, b values, right? Okay, only 2 of these are going to work, and they need to be opposite. So if we can find one of them, maybe try this one. If I square this number, right, I get 16 minus 9 plus 24i, which is 7 plus 24i. Uh-oh, this didn't work because I'm looking for 7 minus 24i. So I need a minus sign, which means this is one of the numbers that I'm looking at, right, or looking for. This is 16 minus 9 minus 24i, which is 7 minus 24i. In other words, one of the square roots of 7 minus 24i is 4 minus 3i, and the other one is the opposite. But that'll be taken care of by the plus minus sign. You see that? So here's what we can do. Replace this square root of that number with 4 minus 3i in parentheses. Where did that go? Okay, 4 minus 3i here. That is the square root of this number. And then go from there. So being lazy here, I don't want to rewrite it. So let's go ahead and do our work here. So the next thing we're going to do is basically simplify this. One of the roots is going to be with the plus sign, like this. And the other one is just going to be with the minus sign, which will negate and give you the other square root. So this will be 6 divided by 2 is 3, minus 2i, which is minus I. This is going to be negative 2, that's negative 1, plus 4i, which is plus 2i. So those are the two numbers you're looking for. Those are the solutions to our quadratic equation. With the other quartic method, it's probably going to be super complicated, don't you think? And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time in another video. Until then, be safe. Take care. Don't forget to check out Cyber Math and aplusbi. And until next time, bye-bye.